use f of x as the square root of x, and g of x is x minus 2. So if I think about those and I color code them, this one blue, this one in green. Square root of x, I know what that graph looks like. X minus 2. I know what that graph looks like. Domain and range for each of these. Well, the blue one, domain is everything. No, wait a second. The blue one, the domain is bigger than or equal to 0. The range is bigger than or equal to 0. And for the green one, the domain is everything. And the range is everything. In part B, an explicit equation for q of x means that we would have square root of x over x minus 2. And we want to see what the graph of this looks like. Okay? So something that we learned from yesterday. If you're dividing graphs, multiplying graphs, adding graphs, subtracting graphs, both graphs have to exist in order for your new graph to exist. Can you see that anything negative is going to be bad? And we can do a table of values. A table of values is very powerful in this one. The smallest one you should be able to plug in is 0. And I hope you can see that if you plug in 0, you get 0. So on my new purple graph, I'm going to have 0, 0. We also know from previous stuff that you're not allowed to divide by 0. So can you see that 2 is going to be bad? Because on our green graph, which is the one we're dividing by, that would make you divide by 0. How does that show up on our graph? It's a non-permissible value that doesn't go away. Again, this reviews chapter 2 a little bit. I like this last unit because it reviews your transformations unit, chapter 2 unit. It's going to review, we did a little review of chapter 1. There's a bunch of review stuff built into this unit. So we're going to have an asymptote there. We need some more points. Okay? First of all, can you see that this purple point is the only place that the blue one is 0? That's going to be your only x-intercept. Okay? If you plug in 1, square root of 1 is 1. 1 minus 2 would be negative 1. You would get negative 1. So as soon as I get that point, I hope you're comfortable with drawing this part towards the asymptote. And it would have to go down because you found that other point. I'd probably plug in 3. Ooh, maybe I wouldn't plug in 3 for mental math. What number do you think I'd plug in? 3 just looks like 4. Yeah. 4. There we go. If I plug in 4, I'm going to get 2 on the top, and 4 minus 2 is 2 on the bottom. I'm going to get 4, and it'll come out as 1. Also, using chapter 2, can you see that this degree is a half? And this degree is 1. And when the degree is bigger on the bottom, you are also going to have an asymptote at y equals 0. So that should be enough for us to say, well, it looks like this is going to go up there, and this is going to go in that direction there. That's helpful because now we can do the domain and range. The domain is x is bigger than or equal to 0, comma, but x can't equal 2. This would be one way that you could write it. Or, if you like interval notation, you start at 0, go to 2, not include 2, start again on the other side of 2, and go on forever. And our range is kind of messed up. This is why our range is kind of messed up. You look at it, your range is everything. Is that a little messed up? Because it has that asymptote in there, and it's not connected, but it's still everything. Because this part on the right is bigger than 0, but not including 0. And this part on the left is less than 0, but includes 0. And you put that together, that's everything. Even though it's not joined. Kind of a little bit messed up. It is very hard to see the range from an equation. You can get your domain from the equation. Because from your equation, domain is which x values are possible. Well, we're doing two things in this that have things that could be bad. You can't square root negatives. So that's why x has to be bigger than or equal to 0. You also can't divide by 0. That's why x can't equal 2. So you can see the domain from your equation. You can see your domain from your graph. You can see your domain from your equation. The range, I look at that equation, I have no idea what the range is. It's like, like literally no idea. It's not until I graph it that I'm like, oh, the range was everything. Okay, questions for practice on this one? 6, 13, and 16.